in this problem, we're asked to find V0 in the circuit below using source exchange. And if you'll recall, when using source exchange, basically we transform from a voltage source in series with a resistor, and we'll just use variables from Thevenin equivalent, A and B. So if we go from a Thevenin equivalent circuit to a Norton equivalent circuit, these are the parameters that describe the source exchange. And if you remember, the relationship here is the following. So we're going to basically go through and do this source exchange through the circuit to solve. So if we look, here's a voltage source in series with resistor. So if we go through and do a source exchange, here's what our circuit becomes. So now we've taken our voltage source in series with resistor on the left side of the circuit, and we've performed a source transformation. Okay, now if we look at our circuit, we've now got two current sources in parallel, so we can combine those together. So current sources in parallel, we can combine them in parallel. So we have 4 milliamps pointing up, 2 milliamps pointing down. So what that leaves us with is a net current of 2 milliamps pointing up. So here's our circuit after we combine those two current sources. So we're left with a 2 milliamp source, so that's 4 milliamps up and 2 milliamps down. Now, again, we can do a source exchange here. We can convert that to a voltage source in series with a resistor. So now that becomes a 6-volt source in series with a 3 kilo ohm resistor. Now we can just calculate V0 by voltage division. So we have 6. We want the voltage across the 2 kilo ohm. That becomes 12 over 9, which is 4/3 of a volt.